Hello, my name is Lindsay Dragon. I'm here to talk about our PF series. PF stands for Power Flash, and this series is our high power strobe lights. Essentially, these lights are more intense and brighter than even overdriving a standard light can get you. The use of this light is just to give a situation enough light to reduce the exposure time where you can achieve an image without getting image blur, or without having to deal with vibration. The faster your exposure time is, the crisper your image will be, the less chance you are to have blur. So by having a light that is up to 8 times brighter than the conventional product, we can decrease our exposure time by that much more. Some features of the light, as I just mentioned, it can be up to 8 times brighter than conventional products. And when I say conventional products, I mean products like our HPD or HPR2 light that are being overdriven. So brighter than them in continuous mode, but also even brighter than them in overdrive mode. With this light setup, we can achieve a minimum strobe time of 1 microsecond. Our lighting delay is built into the controller and can be between 0 and 1,000 microseconds. And this light does compare and is across to the XENON flash lamps. However, it is not the only situation in which we implement this. We implement this anytime we have a situation where we just need to modify with a short exposure time. If you are thinking of swapping with the XENON flash lamp, here's just a little bit of a comparison between the two. The XENON flash lamps have a lot of shortcomings. They're short lifetime of 3,000 hours. They fluctuate in terms of their strobing capacity. They have poor light control and are just not always reliable, versus the PF series is able to overcome every single one of those shortcomings and be a good product for your inspection. One of my favorite parts to point out is that the service life of the PF series is about 50,000 hours compared to just the 3,000 hours from the XENON. There are lots of models and lights that you can get in this series. We have 2 different options for ring lights, the LDR, which is our direct ring light, and the HPR, which is our multi-angle ring light. You can also get bar lights, coaxial lights, and our new dome lights. About 38 models if you include the sizes they come with and the colors red and white. And they also can have the standard accessories that come with the lights, including polarizers for the bar lights and the ring lights, the coaxial light. This series does come with a dedicated controller that must be used with these lights. It can come in 2 channels or 4 channels, and it can have Ethernet or parallel communication and up to 512 intensity levels. The trigger link function allows you to trigger both channels at once with just one incoming trigger. And it has all of the accessories necessary to communicate with your machine. The lighting delay that I mentioned earlier is very important and is built into the controller. The function of this is to make sure that the flash of your light is falling within the exposure period of your camera. If you do not have enough delay, you'll see that the light may flash a little bit early, and therefore not all of the light is within your exposure period, and you're not utilizing the light efficiently, or your image is going to flicker and just not be bright enough in some images or the right intensity in others. At the contrast, if your delay is too long, you'll have the opposite problem where the flash is flashing just a little bit too late. So being able to time up that lighting delay with your exposure time will make sure you're getting the best images possible. So when is this necessary? When do we overdrive? When do we use continuous mode? And when do we need to step up to this PF series? This is a rule of thumb that we've come up with. It is not absolute, it is not certain, but generally this is what we found. If your exposure time is more than 500 microseconds, overdriving should be just fine. Even continuous can work as well. You have a lot of options there. If you're between 500 microseconds to 100 microseconds, you can either use the PF or overdriving will work. That's a little bit more situational. It depends on the light you're using, exactly what's going on. But if you are less than 100 microseconds, then we found that this is pretty much PF series is the only light that can handle this with still getting great images. If we make some assumptions about fields of view and cameras using, this kind of can translate to 100 microseconds being about 75 feet per minute on your machine, or 500 microseconds being about 15 feet per minute on your machine. So if that gives you an idea of when you need to use a PF and when overdriving will work. So here I want to compare the PF series to different kinds of light. So the 3 situations we've compared is normal light with overdriving. So we just took a standard light that we offer, hooked it up to an overdriving controller, and are overdriving it that way. We also stepped it up a light to see just exactly how bright we could get that situation by removing the resistors within the lights to get the max brightness out of the light. The light is no longer as safe, so we don't typically do this, but we wanted to do it for comparison reasons. And then the last we're comparing is the PF series light. So here's the results of the bar light. The bar light is at dark gray, the first one. You can see we're at 1.7 million irradiance, and that's about 3.6 times brighter than the light with the resistors removed and 7.6 times brighter than just normal overdriving. So you can see just how bright this light can truly get. With the ring light, it's even more. We're at 1.8 million lux, and we're 7.5 times brighter than light with the resistance removed and about 25 times brighter than just normal overdriving the light. Coaxial light is also high, where it's at about 600,000 irradiance, but 7 times brighter than a normal coaxial light being overdriven with the resistor removed and 22 times brighter than a normal coaxial light with overdriving. So next I'm just going to talk through an application that we've had in the past that just kind of shows what we were able to get with the normal light and what we were able to achieve with a coaxial light. So here we were just looking at a cardboard box so a printer could make adjustments. We had a 2 megapixel camera, 6-inch field of view. Their exposure time was 75 microseconds. Their line speed was about 200 feet per minute. So we had about 1 to 2 parts per second. So first we tested with the HPR2 150 white. This is a little bit larger of a field of view, but our exposure time was 735 microseconds just to get this image, and it's not even a great image. We did cover up the labels just to keep privacy for everybody, but in the end this is just a cardboard box with a barcode on it. Using the PF light, we were able to get, with a light working distance of about 6 inches and a aperture of 1.8, our strobe width was 14 microseconds. And another example with a strobe width of only 12 microseconds. So it's very drastic how different this light can be in achieving of those very short exposure times. We actually have a live demo prepared so you can see side by side exactly what an overdrive light will do compared to the PF series. So that being said, I will pass this over to Leo for that demonstration.
Hello, this is Leo from CCS America. In this video, I would like to show the PF Power Flash Overdrive light. Here we have a side-by-side comparison. On your left side is the traditional overdrive, which usually give you around 3 times higher intensity compared to continuously on. And on your right side, it is the PF Power Flash Overdrive, which can give you 40 to 50 times higher intensity compared to continuously on. The ratio will vary by different model and sizes, but compared to traditional overdrive, there's a very big intensity increase. And both setups are looking at the same 2D barcode and using the same camera and same lens. And the setting and configuration on the camera and lens are all match each other, same exposure, same aperture. The only difference here is the pulse width. In order to get a good and bright image for the traditional overdrive, the light pulse width needs to be 550 microseconds. On the other hand, for the PF, to get a good image, the light pulse width only needs to be 20 microseconds. And this short pulse width will give a big benefit when the sample is moving in a high speed. Let's turn on the motor and check everything in action. If the motor is moving in a slow speed, like right now, both setups actually work. The traditional overdrive can get a good image. The power flash can also get a good image. But if we begin to increase the speed, you will begin to see the traditional overdrive get a very blurry image, but the PF still get a clean image. Let's keep increase the speed. Let's make it even faster. Like in this speed, we can find out for the traditional overdrive, the image is completely unreadable. But for the PowerFlash, we still get a very good and clear image. So here conclude the PF PowerFlash light. It can give you extreme high intensity, which will be really good for the high speed application. Hope you find this video useful, and thank you very much.